Even though technology is advancing at a rate that blows our minds, no one could have ever guessed that there would come a day when you could get some water from the kitchen sink, pour it into your car's tank, and be good to go on a trip to the supermarket or another state. However, Toyota's announcement about an engine that will soon end the era of electric cars suggests that it is possible for car engines to run on water. But what are the odds that a car can run on only water without fuel or electricity? Stay with us as we explore the new and exciting advancements in car technology and discover all Toyota has to say about their new water engine. Toyota's latest innovation is likely to disrupt the car industry as we know it. Imagine a car powered by water. This mind-blowing vehicle uses an advanced electrolysis process to convert water into hydrogen, which fuels the engine. The engine makes use of the chemical energy released during the recombination of hydrogen and oxygen to produce power, releasing only water vapor as a byproduct. This not only reduces harmful emissions, but also addresses the growing concerns about global warming and air pollution. Toyota's innovation promises a cleaner, greener future for transportation, aligning with global efforts to combat climate change. Although electric cars have been at the forefront of the green automotive movement for years, praised for their zero-emission status and reliance on renewable energy sources, Toyota's water-powered car offers several unique advantages over traditional electric vehicles. While electric cars rely on batteries that require charging from the electrical grid, Toyota's water-powered car uses water, an abundant and renewable resource. The electrolysis process, which splits water into hydrogen and oxygen, can be powered by renewable energy sources such as solar or wind, making the entire system more sustainable. Electric cars have been marketed as zero-emission vehicles, but the production and disposal of lithium-ion batteries pose significant environmental challenges and require a large investment of resources. However, Toyota's water-powered car sidesteps these issues completely. According to the announcement made by the Executive Vice President and Chief Technology Officer, Hiroki Nakajima, at a recent meeting in Japan, Toyota plans to change the future of transportation with this new technology. Nakajima talked about Toyota's big plan to stop being just a car company and start being a mobility company that helps people have many options for movement. He was joined by two other leaders, Takeru Kato, who is in charge of making electric cars called BEVs, and Mitsumasa Yamagata, who will lead the team making hydrogen cars when the factory opens soon. Toyota's hydrogen fuel cell cars work by using a chemical reaction between hydrogen stored in the car and oxygen from the air to make electricity that powers the car. This system includes an important part called an electrolyzer. The process is very efficient and safe, as it doesn't need much energy and doesn't produce any harmful byproducts. One of the best things about this process is that it doesn't need a big, heavy tank to store the hydrogen. The electrolyzer can make hydrogen as it's needed, making the car lighter and more efficient. To use hydrogen fuel effectively, some parts of the car's motor need to be changed. The fuel injectors, which spray fuel into the engine, need to be adapted to spray hydrogen correctly. Also, the engine block and cylinder head need to be stronger to handle the high pressure of hydrogen fuel. Other parts like valves and spark plugs also need to be specially made to help the engine run well and safely. Toyota's water engine is better than other motors that use hydrogen simply because it is much easier and cheaper to store water than to store hydrogen. Hydrogen is a gas, so it needs special tanks that can handle high pressure. These tanks are heavy, expensive, and can leak, which can be dangerous. Water, being a liquid, is much easier to store and doesn't need special tanks or high pressure, making it safer and more practical. This makes the water motor versatile, suitable for small cars, big trucks, and even power plants. Its simplicity and safety make it a better choice than other types of motors, plus it helps reduce our reliance on fossil fuels and cuts down harmful emissions. This makes it a more sustainable option for transportation and energy generation. It may surprise you to know that this whole motive to make a car powered by water only isn't exactly an original idea. The history of water vehicles before Toyota's steps to build cars that run only on water includes several attempts. In 2008, a Japanese company called Genpax announced they had made a car that could run on water instead of gasoline or diesel. This was big news because it promised a cheaper and greener way to power cars. Genpax said their car used a special system to get energy from water by splitting it into hydrogen and oxygen, then using the hydrogen as fuel. But experts found out that the system wasn't just using water. It also needed a special material called metal hydride. This meant the car wasn't truly water-powered. Genpax never provided scientific proof for their claims, and many scientists doubted their story. They explained that water is very stable, and you need a lot of energy to split it into hydrogen and oxygen. According to the laws of physics, you can't get energy from water alone because it takes energy to break the bonds holding the water molecules together. Some scientists also reminded people of Stanley Meyer, who in the 1980s claimed he had made a dune buggy that ran on water. But Meyer never showed solid proof, and his claims were found to be false. He was even convicted of fraud in 1996. Genpax's story sounded a lot like Meyer's, and people were very skeptical. In 2002, Hydrogen Technology Applications said they had a device called Aquagen that could split water into hydrogen and oxygen. They first used it for safer welding but later claimed it could power cars. However, their theories weren't backed by science, and their claims seemed exaggerated. The company later admitted their device could only make cars more fuel-efficient, not run on water alone. Another company, Genesis World Energy, claimed in 2002 to have a device that could get energy from water. They raised a lot of money from investors, but never produced a working product. In 2006, the company's owner, Patrick Kelly, was jailed for fraud. In 2008, the same year Genpax made their announcement, a man in Sri Lanka named Thushra Priyamal de Silva claimed he had driven a car on water for 190 miles using just 3 liters of water. The Prime Minister of Sri Lanka supported him, but Thushra was later arrested for fraud. His claims, like many before him, were exaggerated and misleading. More recently, in 2022, Arianto Mel from Indonesia claimed to have made a device called Nkuba that could turn water into hydrogen fuel. He said it could power motorcycles for 500 kilometers on 1 liter of water, and that big car companies like Lamborghini and Ferrari were interested. But scientists in Indonesia doubted his claims, saying the device was impossible according to physics. They also found out that the car companies weren't really interested. Arianto's story, like others, seemed to be more about making bold claims than having real proof. Despite these failed attempts and scams, we have to wonder if there has been a deliberate attempt to stifle the usage of water as fuel for vehicles. While we certainly can't prove that there have been suppressions, there are many reasons why this might be so. For one, the global energy industry, currently dominated by fossil fuels, is worth trillions of dollars. Introducing a technology that could make traditional energy sources a thing of the past threatens the financial interests of powerful corporations and stakeholders. These entities have enough resources and influence to suppress or discredit technologies that could threaten their market dominance. For example, fossil fuel companies have a vested interest in maintaining their market share and may lobby against or discredit alternative energy technologies to protect their profits. Another probable reason is that new and innovative technologies often face skepticism and resistance from the public and media. It is understandably hard for the public to understand how water could be used to fuel a vehicle, and the perceived risks, safety concerns, and lack of understanding can lead to negative publicity and hinder widespread acceptance. Powerful entities may also choose to exploit these fears to maintain control over the narrative and suppress these potentially disruptive technologies. Misinformation campaigns can create doubt and fear around new technologies, making the public less likely to accept them. However, with Toyota publicly stating its plans to develop these cars while presenting evidence on how the science works, it is entirely possible we are about to see the dawn of a new age. Their influence in the mobility market, the trust they have built over the years, and their deep pool of resources suggest that we will see water vehicles become a reality rather than just hearsay. All this is a result of Toyota's desire to stay ahead in a market that is moving towards clean technologies and electric vehicles. Especially with new electric cars coming from companies like BYD and Xiaomi in China, it has led them to focus on making their hydrogen technology better and more efficient to meet the growing need for environmentally friendly transportation. This history of water-powered car ideas shows that while many claims might have been false, the push for greener energy solutions is real and important. Toyota's ongoing research has already produced a car, the Mirai, that is powered by hydrogen, and these advancements prove that a more sustainable future in transportation is possible. There is still more to come. In comparison with China and America in electric vehicle production, it is common knowledge that in the race towards sustainable transportation, China and the United States have been leading the charge in electric vehicle (EV) production. China, with its aggressive policies and significant investments in EV infrastructure, has become the largest market for electric vehicles. Companies like BYD, NIO, and XPeng are heading China's EV revolution, benefiting from government subsidies, extensive charging networks, and robust manufacturing capabilities. The Chinese government's commitment to reducing carbon emissions and urban pollution has led to tough regulations that favor the adoption of EVs. As a result, China's EV market has seen fast growth, with millions of electric cars sold annually. The country's focus on developing battery technology and expanding its charging infrastructure has also played a crucial role in maintaining its position as a global leader in EV production. In contrast, the United States, home to top companies like Tesla, has also made significant strides in the EV sector. Tesla, under the leadership of Elon Musk, has revolutionized the market with its innovative designs, cutting-edge technology, and expansive supercharger network. The company's commitment to improving battery efficiency and range is continuous, increasing standards for the industry. Legacy automakers like General Motors and Ford have shifted their focus towards electric vehicles, introducing new models and investing heavily in EV technology. However, despite the progress in EV production, both China and the United States face challenges related to the environmental impact of battery production and disposal, as well as the need for sustainable energy sources to charge these vehicles. This is where Toyota's water-powered car presents a unique advantage. Toyota's innovation in developing a vehicle that runs on hydrogen derived from water sets it apart from the traditional EV approach. Unlike battery electric vehicles, BEVs, which rely on large lithium-ion batteries, Toyota's water-powered car utilizes hydrogen fuel cells. This difference not only addresses some of the environmental concerns associated with battery production but also offers a cleaner alternative in terms of emissions. By producing only water vapor, Toyota's engine eliminates the release of harmful pollutants such as carbon dioxide, nitrogen oxides, and particulate matter, which are common with fossil fuel-powered vehicles. Toyota's hydrogen fuel cell technology offers several advantages over conventional batteries used in electric vehicles. For instance, hydrogen fuel cells can be refueled much faster than recharging a battery, often taking just a few minutes to fill up a hydrogen tank compared to several hours needed to recharge a battery. This makes the water-powered car more convenient for long-distance travel and reduces downtime for refueling. Another major advantage of hydrogen fuel cells is their higher energy density compared to lithium-ion batteries. This means that hydrogen fuel cells can store more energy per unit of weight, potentially providing a greater driving range for vehicles. Plus, Hydrogen can be produced using various renewable energy sources such as solar, wind, and hydroelectric power, further enhancing the sustainability of this technology. Toyota's approach also addresses some of the key challenges faced by the EV industry. For example, the reliance on lithium-ion batteries in electric vehicles has led to concerns about the environmental impact of mining and processing the raw materials needed for these batteries. Additionally, the disposal of used batteries poses significant environmental risks. By focusing on hydrogen fuel cells, Toyota's water-powered car offers a more sustainable solution that can help mitigate these issues. In conclusion, Toyota's water-powered car represents a significant step forward in the quest for sustainable transportation. While the history of water-powered vehicles is filled with false claims and scams, Toyota's commitment to developing this technology, backed by solid scientific principles, suggests that a future where cars run on water is not just a dream, but a real possibility. The company's innovative approach, combined with its extensive resources and influence in the automotive industry, positions Toyota to lead the way in this new era of clean, green transportation. As we move forward, it will be fascinating to see how this technology evolves and how it will shape the future of mobility. Toyota has made significant advancements in hydrogen production and storage, addressing key challenges in the hydrogen vehicle sector. The company has developed advanced electrolysis units that are more efficient, reducing the overall energy consumption required to produce hydrogen from water. These units utilize cutting-edge catalysts and materials to enhance the efficiency of the electrolysis process, making large-scale hydrogen production more viable. In terms of hydrogen storage, Toyota has innovated with high-pressure tanks made from advanced composite materials. These tanks are designed to be both lightweight and extremely durable, ensuring the safe storage of hydrogen under high pressure. The storage system is equipped with state-of-the-art sensors and safety features to detect and prevent leaks, providing an additional layer of security. One of the challenges Toyota has addressed is operating hydrogen vehicles in cold climates. Hydrogen can freeze at extremely low temperatures, potentially affecting the vehicle's performance. To overcome this, Toyota developed innovative solutions such as incorporating heating elements and insulation into the hydrogen storage system. These measures ensure that the vehicle can operate reliably even in harsh winter conditions, making hydrogen vehicles viable in a wider range of environments. Toyota's commitment to integrating renewable energy sources into the hydrogen production process aligns with global efforts to reduce reliance on fossil fuels. By using solar, wind, and hydroelectric power to generate hydrogen, Toyota's water-powered car can operate with a minimal carbon footprint, making it a truly green alternative in the automotive industry. Toyota's commitment to eco-friendly technology goes far beyond its development of hydrogen fuel cell vehicles. The company has been a pioneer in both hybrid technology and the exploration of alternative fuels. One of the notable areas of focus has been the development of hydrocarbons with reduced environmental impact. Hydrocarbons in their conventional form, such as gasoline and diesel, contribute significantly to carbon emissions. However, Toyota has been exploring the use of synthetic hydrocarbons and biofuels that can serve as cleaner alternatives. Synthetic hydrocarbons are produced through chemical processes that convert carbon dioxide and hydrogen into fuels, effectively recycling CO2 and reducing the net carbon footprint. Biofuels, derived from organic materials such as plant biomass, animal waste, and algae, present another promising avenue. These fuels are renewable and can be produced sustainably. Toyota has invested in research to improve the efficiency of biofuel production and to integrate these fuels into their vehicle lineup. By researching and developing these alternatives, Toyota aims to provide immediate solutions for reducing emissions while the infrastructure for hydrogen and electric vehicles continues to expand. In addition to hydrocarbons, Toyota has made major developments in fuel cell technology. The core of Toyota's eco-friendly vehicle strategy lies in hydrogen fuel cells, which convert hydrogen gas into electricity through a chemical reaction with oxygen. This process produces only water vapor as a byproduct, making it one of the cleanest forms of energy. Toyota's first fuel cell vehicle prototype was unveiled in the early 1990s, and the technology has evolved substantially since then. Today, Toyota's fuel cells are more efficient, compact, and cost-effective. Advancements in fuel cell technology have been driven by improvements in catalyst materials, membrane durability, and overall system integration. As of recent reports, Toyota holds over 5,000 patents related to hydrogen fuel cell technology. These patents include key advancements in fuel cell stack design, hydrogen storage solutions, and methods for efficient hydrogen production. By securing these patents, Toyota not only protects its technological innovations, but also positions itself as a leader in the transition to sustainable transportation. One of the most significant milestones in Toyota's journey toward eco-friendly technology is the introduction of the Mirai, the world's first mass-produced hydrogen fuel cell vehicle. The Mirai, which means future in Japanese, embodies Toyota's vision for sustainable mobility. Launched in 2014, the Mirai has since undergone several updates and improvements, reinforcing Toyota's commitment to advancing fuel cell technology. The Mirai operates using a hydrogen fuel cell system that generates electricity through a chemical reaction between hydrogen and oxygen. This system consists of several key components, including the fuel cell stack, high-pressure hydrogen tanks, an electric motor, and a battery for energy storage. The fuel cell stack, often referred to as the heart of the vehicle, is where the electrochemical reaction occurs, producing electricity and water vapor. One of the notable features of the Mirai is its impressive driving range and refueling time. With a full tank of hydrogen, the Mirai can travel over 300 miles, comparable to many gasoline-powered vehicles. Refueling the Mirai takes only about 5 minutes, significantly faster than recharging an electric vehicle. This convenience makes the Mirai a practical choice for consumers looking for an eco-friendly vehicle without compromising on usability. The environmental benefits of the Mirai are substantial. By emitting only water vapor, the Mirai eliminates tailpipe emissions, contributing to cleaner air and reduced greenhouse gas emissions. Toyota has also taken steps to make the Mirai accessible to a wider audience. The company has implemented various initiatives to reduce the cost of hydrogen fuel cell vehicles, including advancements in manufacturing processes and economies of scale. Furthermore, Toyota has been actively involved in partnerships and collaborations to expand the hydrogen refueling infrastructure, making it easier for consumers to adopt hydrogen vehicles. Beyond the Mirai, Toyota's commitment to hydrogen technology extends to other vehicle segments. The company has developed hydrogen fuel cell buses and trucks, showcasing the versatility of this technology in different transportation applications. These vehicles are designed to provide clean and efficient transportation solutions for public transit and commercial operations, further reducing the carbon footprint of the transportation sector. In addition to its vehicle offerings, Toyota is exploring the use of hydrogen fuel cells in stationary applications. The company has developed hydrogen-powered generators and energy systems that can be used in buildings, data centers, and other facilities. These systems provide a reliable and sustainable source of energy, further demonstrating the potential of hydrogen technology beyond the automotive industry. Toyota's approach to eco-friendly technology is holistic and forward-thinking. The company recognizes that achieving a sustainable future requires a multifaceted strategy that includes not only innovative vehicles, but also the development of supporting infrastructure and sustainable energy sources. The electrolysis process is crucial in Toyota's hydrogen fuel cell products, as it involves using a chemical reaction between the hydrogen stored in the vehicle and the oxygen in the air. This reaction produces electricity, which powers the car in an efficient and environmentally friendly manner.